Hello. Recently I was given this SL-3000 very early beta portable video recorder, if you can call this huge monster portable. I've repaired one of these before, so let's get stuck in and see if we can fix this one. Here is our monster SL-3000 portable video recorder with its even more monster power supply, which got a huge transformer in it. And if you saw my last video, you'll see that the fault condition is the following. If we select play, we can hear something, but nothing happens. But if we hit fast forward, we get a little bit of fast forward before it shuts down. It's just the momentum of the spinning motor that drives fast forward. If we hit fast forward again, nothing happens at all. Similarly, rewind, nothing will happen unless we select play first, get the motor spinning up, and then rewind, and we get a few seconds of rewind. Eject and unlace do work properly, so we'll just do that. Right, let's take this cover off and then take the cabinet work off and see what's going on. An interesting type of screw they've used here. They're flat blade with a locating pin in the middle. Right, I'm trying to gain some access to the bottom of the board, the bottom of the deck, but it's not that easy because this panel's in the way and it doesn't swing out of the way. It's held on by lots of connectors. But here you can see a drive belt from the head motor to, I think that's going to the rear drive. And that may be part of our problem. Not sure yet. There's a little bit of slack on it, but I'm not sure it's enough to stop it from working. There's also a drive belt here, which I think is part of the eject mechanism, I suspect. No, it's a loading belt. And again, that seems to be tolerably good condition. Access is really awkward here. I don't want to touch this against the frame. I could finish up shorting something out. Another belt I can see here is Capstan, and that appears to be stalled. So here's the Capstan flywheel, and here's the Capstan motor, and the Capstan motor seems to be jammed. I'm not sure if it's the belt or the motor that's failed. Oh yes, now I remember. Last time I worked on one of these I had the same problem. The Capstan motor was seized and needed a bit of encouragement to get it going again. So here's the Capstan motor, great big thing. Looks like it would never fail. But that is clearly seized. So there's the grub screw at the end attaching. I don't know if you can see that. Let me give you a better view. So the plastic cover over it, and then here's the shaft for the Capstan motor, and there's a grub screw attaching a pulley to the shaft, and I can't turn it. Perhaps I could drop some oil down the shaft here. Just maybe that might help free it up. Let's try that. Okay, I've taken the plastic cover off. I've also taken a metal piece off the other side, so we've got better access to the motor. And having oiled it, I can now turn the shaft just a bit, but it's still stiff as a board. Really terrible. So I'm going to disconnect the wires there, and from the FG sensor there's a connector underneath there. Just about see it. And undo the 3 screws at the top and take the motor out and see what we can do with that motor. There's a magnetic shielding here we can remove. Allowed me to get a little bit more WD-40 down here, but that's not helping. But it does give us the model number, BHF1100D. That's the motor type we need to obtain. Well, I wasn't too sure about whether we could do anything with this motor, but a big shout out to Retro Gadget Man, who has done a YouTube video on exactly this thing and how to dismantle this motor and get the shaft unjammed. So let's do what he suggests. There we go. And we can slowly pull the shaft out, and this is what's wrong. Okay, this is nowhere near as easy to spin as it should be. So the problem is that this shaft is fouling on this bearing. It should be much easier to spin. Turning it the wrong way around for a minute, but that seems to work quite easily that way. Yes, inserting it the wrong way seems to work just fine. Let's put it back the right way. It may be that just removing it and putting it back has got the oil or WD-40 in all the right places, and it's now in good working order. So I think what was happening was the lower bearing here needed lubrication. I think our problem was that it was the lower bearing here that needed the lubrication, and putting oil in the top there wasn't enough. I'll clean the shaft a bit. I'll apply some fresh oil to both bearings, and I think we can reassemble that with no further ado. And a drop of oil on the end as well here, I think. Right, I need to fold these tabs back over without pushing this top plate too far down and affecting the clearances, and then refit the pulley. Okay, the tool that I found worked for the pulley there was iFixit 1.3mm hex drive. So that is now absolutely beautiful, spinning a treat. I can refit that back to the machine. So reconnect the motor drive there, and then the FG generator with the white connection going to the right hand side, because they're not polarized. Okay, we're bound to have other issues to solve, but at least we've got the Capstan motor running, so let's see what happens now. Stupidly, I left it in the laced condition. That may have somewhat annoyed it, so I'm going to have to try to unravel that mess. Try that again. What's wrong? Seems like this belt is slipping. Let's replace that belt. Okay, suitable replacement belt is inserted there. Laced up. Okay, we'll try play and see if we get any capstan rotation. Well, we did. Yes. Took a moment. That's looking a little bit happier. I suspect the fast forward problem we had was nothing to do with this, so let's try fast forward. I don't think that's going to work. Oh, it does work. Sort of. No, it doesn't. It's still relying on that head drum rotation. So we have a separate problem there with the head drum is not being commanded to spin during fast forward and rewind. Okay. But we could have a look now to see if we have any video output during play. Okay, let's try a tape with a test recording on it. And that's apparently working. Let's find the tracking control. Ergonomics of the tracking control are not very good. Yeah, I sent the Capstan servo into a spin. Hit pause and see if it can come back from there. Where's pause? So we seem to have two issues. The Capstan servo locking isn't very good, which could be capacitors in the Capstan servo, or it could be that the free run speed is set right on the edge and so it's struggling to capture it. And we don't have any fast forward and rewind because it's not driving the head drum motor during fast forward and rewind, and it's a head drum that does the real drive. Okay, let's eject the tape. Actually, there was one other problem, wasn't there? When I selected play, it didn't engage the first time. Let's just prove that again. Hit play and it dropped out. Oh, well, it's not doing it now. But initially it dropped out and I had to restart it. Try that again. Okay, that seems to be working fine now. But fast forward only works for as long as the drum keeps spinning. Alright, shall we look at the fast forward rewind problem first? Let's look at this. There are actually two micro switches here. Well, they're leaf switches. One for fast forward and one for rewind. Here and here. They can't be the cause because neither fast forward nor rewind works, but we'll prove the point. So if I hit rewind and then we hit fast forward. Okay, so not those. I really could use the service manual to this machine. Well, I don't have the schematics yet, but what I have worked out is there's a 12 volt supply to the motor driver chip for the drum motor. Appears at pin 14 here, and that's connected through to this connector CN4's red wire, which feeds through to the syscon panel. Not surprisingly then, really, that the syscon supplies 12 volts to the drum circuit and various other components run off that 12 volts. So I'm going to trace that back to the syscon board and see if we can work out why that 12 volts is there during play but not during rewind and fast forward. and having looked at somebody else's video, I see that it wouldn't normally be there during eject. Right, so I'm going to put this board back again and look at where this red wire here appears at the syscon panel. Let me show you what I've got set up here. On this side we have the syscon board and system control. On this side there's some audio and also motor drivers. So the part we're interested in over here, you can just about maybe see, let me get it closer for you. There's the drum servo chip, and pin 14 of that goes to 12 volts when the play operation is selected, and that 12 volts comes back through here to this this connector, and that itself is driven from connector over here and to this point here. So here is 12 volts during play operation, and that will need to be 12 volts at any time that the head drum is supposed to be spinning. So if we monitor that, now the machine is upside down and it won't like it very much, but this is the play button and that goes to 12 volts. It may not latch in, it doesn't like being upside down, but that 12 volts allows the drum to spin. Now the head drum should be spinning during fast forward and rewind because the head drum motor via drive belt drives the reels. But if I hit fast forward or rewind, nothing's happening, even though the switches for fast forward and rewind, which are these, are just fine. And I've also checked a couple of micro switches that are in here. So there's a problem with electronics probably in here, where it should, during rewind and fast forward, also power up the 12 volt line. It's probably a bad transistor. Now, looking at the diagrams I do have for an SL-3000, I found that there's an assortment of transistors and sort of logic which dictates when the 12 volt lines are operated. But the SL-3000, despite having a similar chassis to this, is quite a different machine. It's a lot logic controlled rather than mechanical. So we can't read too much into that. I really need the schematics for the SL-3000. It wouldn't probably matter much if I was looking at schematics for an NTSC model, because this part of the electronics is likely to be the same. There would be differences elsewhere because the NTSC model can run at least 2 speeds, whereas this, of course, being PAL, is single speed. So there we are. We have this 12 volt line which is not being operated during fast forward and rewind, but we desperately need the schematics in order to make any sense of what is wrong with where it goes from these switches through to the electronics that drives the drum motor in fast forward and rewind. Looking at the switches here for rewind and fast forward, here's rewind, and you can see that the pins go to 12 volts. Both sides of that switch go to 12 volts when it's selected, and similarly for fast forward. But the electronics then that go from here to here are an unknown. Okay, so to progress this, we really need the schematics for the SL-3000. If anyone out there can help, please let me know, and we can work on this machine some more. In other matters arising, do you remember the other day we had a Beta Hi-Fi SL-HF100 with a bad gear? This had split. Well, it turns out that some remote control car gears can be used in place of this. I've ordered some of those, so when they come in we'll give that a whirl. Another thing I'm planning on working on, which is not video related but is different, is this is a remote control blipper for a Toad alarm system which I have installed in my Toyota. So there's a Toyota key and there's the Toad remote, and the buttons wear out really badly on these, the labelling wears off, and the boot release one's not labelled anyway, and it's just a bit nasty ergonomically, and you just can't buy these empty shells anymore. You used to a year or so ago, but you can't get them anymore, and they always wear like this one. So I've had a think. I bought several more second-hand blippers, and these are working, and I've programmed these to the car. In fact, one of them is in here now. So even though these were only 2-button blippers, the electronics behind it will take up to actually 5 buttons. So this is now fully working. If I press that button, it'll unlock the boot of my car outside. But it's still clunky. You've still got this worn-out button thing. What I'd really like, of course, would be a nice arrangement like a modern car. Something like a remote like this, which has got nice clear buttons on it, and a key inside. A Toyota key, that's a blank. So my plan would be, can I miniaturize the electronics in there, reconfigure where the buttons are, and mount it in this tiny space here, and get it so that the buttons that are supplied here, or the places where buttons are, will actuate switches for the electronics there. And towards that, I've bought from China a good selection of key switches as used in remote controls. They could be useful for many things, including video anyway. But it's going to be a real challenge to shrink that into that space. They use a smaller battery as well, and I can't seem to work out how the battery hatch works. It seems to keep falling apart. So that's going to be extremely challenging to get the circuit board from one of these miniaturized. So let's pull it apart and have a look at what I need to do. So all that needs to be shrunk into that space. It looks impossible, doesn't it? But the point is, there's no actual electronics beyond here. So I could cut the PCB and somehow squeeze the useful part of the PCB into that space, and then build up the switches and use a smaller battery as this keyfob does. So that could be an interesting challenge. I'll do plenty more content on audio and video electronics and other interesting projects like this in the near future, and please let me know if you can find the diagrams to the SL-3000 in preferably PAL, but would take NTSC as well. Bye for now.